All right, more establishing identities today, you guys. We're going to have a little twist to this just to make this a little bit more entertaining. I know it's a little bit cheesy, but we can do this. Here's a little hint about how we're going to approach this today. All right, I think that's enough of a hint. You can see that this is like big time CSI style, okay? You've been asked to use your specialty with identities to solve a few trigonometric crimes in your area. First assignment, function robbery. You think you have tracked down the criminal, tangent minus cotangent over tangent plus cotangent plus 1, but he has hidden his true identity. If you can verify that 2 sine squared is in fact his cover-up identity, then you will have finally caught the infamous criminal. Good luck. Okay, cheesy, I know. What you really have to do is prove this, okay? So here we go. Here's the first example. Again, like I've told you many, many times, when in doubt, change everything to sines and cosines, and that's what I would do here too. So I'm going to use my trig properties, and I am going to know and remember that tangent can be replaced with 1 over cotangent. Probably not going to do me much good since I have sines over here. So I am going to replace tangent instead with sine over cosine. And cotangent can be replaced using my trig properties with cosine over sine. And I'm going to do the same thing on the bottom here. Okay, and then I can't forget about this plus 1 that's back here. All right, now I've got fractions within fractions, which is ugly, and I need to get some common denominators here. So if I look at this, my common denominator between cosine and sine would be sine cosine. So I need to multiply this by sine over sine so that I have a common denominator, and this by cosine over cosine. Okay, same thing on the bottom. My common denominator is sine cosine, so I will multiply this by sine over sine, and this by cosine over cosine. I'm going to leave my 1 back there for now. I'm going to just deal with this ugly fraction. So what happens here is I have sine times sine, which is sine squared, minus cosine times cosine, which is cosine squared. So I have sine squared minus cosine squared over my common denominator down here, which is sine cosine. Okay, and then the bottom will be the same, except for there's a plus sign in there. And again, don't forget about your plus 1 back here. Okay, now, so some good things happen here. First of all, you've got at least one identity in there. Sine squared plus cosine squared you know is 1, so always be looking for that. Sine squared plus cosine squared is 1, so I am going to take this out right here and make it be 1. Then I've got this double fraction, so instead of multiplying or dividing by that fraction, I am going to multiply by its reciprocal. So I'm going to multiply by sine cosine over, again, the quantity 1 can be replaced with sine squared plus cosine squared. So that's gone. Okay. And now sine cosines are going to cancel like that. And what I have left is this quantity. And then don't forget about your plus 1 back here. Okay. Then if I scroll up, I kind of want to look at what I need to get to. I need to get to 2 sine squared on the right side. I need to get to 2 sine squared, and somehow I've got this cosine squared in there. So you can do a couple different things. You could replace cosine squared with its identity and distribute the negative through. Or you can realize this. 1 minus cosine squared, which by the way is also the same as negative cosine squared plus 1. But that can be replaced with sine squared. So I can take this quantity down here, and this is an identity. 1 minus cosine squared, or negative cosine squared plus 1, is an identity which can be replaced with sine squared. And so now I have sine squared plus sine squared, and I have 1 sine squared plus 1 sine squared, which makes 2 sine squared. And I have turned the left into the right. All right, let's see what our next crime is. Identity theft. Poor so-and-so there has had her identity stolen. We think the thief is using the identity sine plus cosine instead. If you can verify that those two quantities are equal to each other, you will be able to return that person's identity. All right, here's what you really need to do. Okay? So again, when in doubt, change everything to sines and cosines. Notice you've got that tangent and that cotangent there, which are kind of oddballs because everything else in there is sines and cosines. So I am going to replace tangent using its trig properties. I could replace that with 1 over cotangent if I wanted. I could also replace it with sine over cosine. It's not squared, so I can't use any identities to replace it. Okay, so I'm going to replace this tangent right here with sine over cosine. And I'm going to replace this cotangent with cosine over sine. Okay? And now what I need to do is I need to think about, and I'm actually going to try and, oh, that's not going to work. I need to think about how I am going to get common denominators here. So I'm first of all going to worry about getting this as a common denominator. Right now this is 1 over 1. And so I'm going to replace this with cosine over cosine. So what I have here is I have cosine over, and then right here I have cosine minus sine over my common denominator, which is cosine. Plus, and then over here, again, I am going to change this 1 over 1 right here into sine over sine so that I have common denominators. Okay, so then I will have this. I will have sine on the top over sine minus cosine over my common denominator, which is sine. Okay, then what I'm going to do is I've got these double fractions here that I need to deal with, so I need to flip them. So instead of dividing by this quantity, I can multiply by its reciprocal. Okay, so that's gone. Same thing here. Instead of, whoops, I messed that up. Cosine minus sine, it should be. Okay. And then, instead of doing this one, I can multiply by its reciprocal. So I will multiply by sine over sine minus cosine. Those will cancel out. So now what I have is this. Cosine times cosine right there is cosine squared over cosine minus sine. Plus in the middle, sine times sine is sine squared over sine minus cosine. Okay, now I want us to kind of take a little breath here and figure out where we are and where we need to be. So if you look at this, it almost looks like we have common denominators, but we don't quite, which is kind of a bummer. I need to get this quantity to sine plus cosine somehow. Okay, so when I need to be able to add these two fractions together somehow, and I don't have common denominators. If you think about this and I switch these two around, I'm going to switch these two around right here, then I will have just, I can rewrite that as negative cosine plus sine. Okay, which is similar to this one over here, but it's not the same. What you'll notice is that this is positive cosine and negative sine. This is negative cosine and positive sine. So they're opposites of each other. So really what you can do is you can factor a negative 1 out of here. And if I factor a negative 1 out of here, then I will have positive cosine minus sine. Okay? So I'm going to just kind of rewrite this and clean this up a little bit. I haven't touched anything over here. Over here I have this. Okay, and what I'm going to do then is I'm going to take this negative 1 and I'm going to move it to the top. I'm going to put that negative sign on the top instead. So instead of me having sign divided by negative 1, I'm going to change this and I'm going to move it to the top instead because it's still going to give you a negative quantity. And now you'll see that you have common denominators. Okay, so now what happens is I have common denominators and I can take cosine plus negative 1 times sine. Oops, I forgot my squared over here. And then my common denominator would be cosine minus sine. And I'm almost there. Okay? Obviously, when you add a negative 1 times sine, what you're really doing is you're taking this, cosine squared minus sine squared. Okay? And then cosine squared minus sine squared is not an identity. It has to have a plus sign in it in order to be an identity, so it's not, but it is a perfect square, and it can be factored as cosine minus sine and cosine plus sine. And what a lot of people want to do is they want to be able to cancel, again, one of those with one of these, but that's not legal. Okay? Can't do that. Can't separate those quantities that have addition and subtraction signs in there. So now I'm here. And luckily, these two quantities right here can be canceled. And I have cosine plus sine, which of course can be switcherooed around since it's addition, and make it be sine plus cosine. And that is what I need to get. Phew-da. All right, last crime right here. Diamonds have a unique serial number inscribed on the side of them in very tiny writing. Trig Jewelers is asking for your help. They think that one of their largest diamonds has been stolen and replaced with a diamond that has a fake serial number. The diamond's serial number is brrrt. The diamond that is now the case has the following serial number. In order to prove that the diamond in the case is an imposter, you need to verify that identity. Okay, cheesy? I know. Here we go. This is actually really quick. Sometimes you're going to have this, and the easiest thing to do is to split the fractions up. And so when I split the fraction up here, this is what it's going to look like. I'm going to have cosine over my denominator, which is sine, plus sine over sine, minus sine cubed over sine. Okay? And when you do that, cosine over sine, if you use your trig proportions, cosine over sine, when you look at this, cosine over sine is cotangent. Where is this? Cosine over sine, right here. Cosine over sine is cotangent. Okay, sine over sine is 1. So I have cotangent plus this quantity is 1. And then sine cubed over sine would simplify to sine squared. And then you have to somehow get a cosine squared in here, but luckily this quantity right here, 1 minus sine squared, if you look over here, is an identity. 1 minus sine squared is an identity for cosine squared. Okay? So you will have cotangent theta plus cosine squared theta, and I have just turned the left into the right. Hallelujah. Oh, we have one more. All right, last one right here, I guess. Okay, here we go. I am going to, I know what I wanted to do here. I wanted to show you this. Sometimes, and you're going to get a couple of these like this, and I'll tell you which ones they are in your homework, but sometimes you're going to get ones where what you want to be able to do actually is divide everything through by something. And so when you divide everything through by something, in this case, here's what I want you to notice. Sine, if you look in the same position in the other side, sine has to turn into 1. Okay, sine has to turn into 1. So what would you divide sine by to turn it into 1? Well, you'd have to divide it by sine. And if you divide that term by sine, you have to divide every term by sine. Okay? And now what happens is sine over sine becomes 1, sine over sine becomes 1, and cosine over sine becomes cotangent. and you have just turned the left into the right. Okay? So that'll do it for you. And you are going to have a worksheet as your homework next time I see you.